Have you ever wondered if our tiny blue planet is just one of many? What if Earth isn't the only place where life can thrive? Could there be another world waiting for us beyond the stars? A second Earth? Welcome to Starsky Science. If you're passionate about space, discovery, and the big questions of human survival, make sure you hit that subscribe button right now so you never miss our journey into the cosmos. Today, we set out on one of humanity's greatest quests, the search for a new Earth and the possibility of life among the stars. The Earth, our cradle, our sanctuary, our only home for nearly 4.5 billion years. Here, on this fragile planet, life has blossomed against impossible odds. Yet, as we look deeper into the universe, one truth becomes clear: Earth will not last forever. Whether through climate change, natural disasters, asteroid impacts, or the eventual death of our sun, one day our species will have to face a choice: adapt or perish. This is why scientists, astronomers, and dreamers are asking the biggest question of all: can humans survive on other worlds? And if so, where do we go? Exploration is written into our DNA. From the first humans crossing continents to the Apollo astronauts leaving footprints on the moon, we have always looked beyond the horizon. But the challenges of space are unlike anything we faced on Earth. Leaving Earth behind is not simply about finding another rock to stand on. It's about finding a planet with the delicate balance of conditions that can support life. A place with water, air, gravity, and protection from deadly radiation. A world that could be called a second Earth. But how close are we to finding such a world? And what would it really take to survive there? The hunt for Earth-like worlds began in earnest in the 1990s. In 1992, astronomers Alexander Wolszczan and Dale Frail discovered the first confirmed planets outside our solar system, orbiting a pulsar 0 light-years away. These worlds were hostile, blasted by deadly radiation. But the discovery proved something extraordinary. Planets are everywhere. Since then, NASA's Kepler Space Telescope and later TESS, the Transiting Exoplanet Survey satellite, have revealed thousands of exoplanets, worlds orbiting stars beyond our sun. And among them, some are strikingly Earth-like. Astronomers now believe that in our galaxy alone, there could be billions of Earth-sized planets. Statistically, there must be many worlds that could support life as we know it. The Kepler mission, launched in 2009, changed everything. It used the transit method, watching stars for tiny dips in brightness as planets passed in front of them. By doing this, Kepler revealed that small, rocky planets are not rare, they're common. One of its most famous discoveries was Kepler 186, an Earth-sized planet orbiting in the habitable zone of its star, 500 light-years away. It was the first planet scientists found that was similar in size to Earth and within the right temperature zone for liquid water. Other promising worlds followed: Kepler 452b, sometimes nicknamed Earth's cousin, and Kepler 22b, a super-Earth with possible oceans. Each discovery brings us closer to answering the question: is there another Earth out there? But finding a second Earth isn't just about size or distance. A truly habitable planet must tick a very specific list of requirements. Liquid water, the foundation of life as we know it. Atmosphere, to shield life from radiation and maintain temperature. Gravity, strong enough to hold an atmosphere, but not so strong that humans can't survive. Temperature, within the Goldilocks zone, not too hot, not too cold. Stability, a planet that isn't bombarded by constant asteroids or extreme solar flares. Even with these conditions, there's no guarantee life or humans could survive there. But these are the starting points that scientists use to filter the thousands of exoplanets discovered. One of the most intriguing discoveries is Proxima Centauri b, orbiting the star closest to our sun, just 4.2 light-years away. Proxima b is in the habitable zone, where liquid water could exist. It's tantalizingly close in cosmic terms. But there are challenges. Proxima Centauri is a red dwarf star, prone to violent solar flares that could strip away the planet's atmosphere. If Proxima b has a strong magnetic field, it might protect life. If not, it could be a barren, irradiated world. Still, the discovery raises the possibility that the first, second Earth might not be hundreds of light years away, but just next door. Then came one of the most exciting discoveries of recent years, the TRAPPIST. One system, 7 Earth-sized planets, orbit this tiny star 40 light years away. 3 of them are in the habitable zone. Imagine a whole system of potentially livable worlds orbiting a single star. Astronomers dream of sending probes to TRAPPIST-1, but even at our fastest speeds, it would take hundreds of thousands of years to get there. For now, we can only study them from afar. If you're enjoying this journey through space, don't forget to subscribe to Starsky Science. Your support helps us bring you more in-depth explorations of the universe and the mysteries of life beyond Earth. Even if we find the perfect second Earth, surviving there is another story. Humans are adapted to Earth's unique conditions. Our atmosphere, our 24-hour day, our gravity, all of it is finely tuned to life here. On another world, we may face crushing gravity, poisonous air, deadly radiation, or endless storms. Even the length of a planet's day could impact human biology. That means survival will depend on technology, adaptation, and resilience. NASA and other space agencies are already studying how humans could adapt to long-term life beyond Earth. From building domes and habitats that protect us from radiation, to developing closed-loop life support systems that recycle air and water, we are taking the first steps toward living off-world. So, as we begin this epic journey, we've seen that the universe is filled with planets more than we ever dreamed. Some may be Earth-like, some may be harsh and alien. But the question remains, can we find a true second Earth? And can we call it home? In the next chapter, we'll dive deeper into the incredible discoveries of exoplanets, the tools astronomers use to study them, and the breathtaking possibilities of life beyond our solar system. This is just the beginning. Stay with us on Starsky Science as we continue the search for a second Earth. In our last chapter, we began the great cosmic journey exploring the thousands of exoplanets discovered by astronomers and asking whether one of them could be our future home. Today, we'll go deeper. How do scientists actually find these distant worlds? How do we know if they can sustain life? And what secrets are waiting in the light of the stars? If you haven't yet, make sure you subscribe so you don't miss the next steps in this incredible quest. Every great journey begins with tools. For explorers of the past, it was ships and compasses. For us, in the search for other worlds, our ships are space telescopes, and our compasses are the laws of physics. The Kepler Space Telescope, launched in 2009, was humanity's first true planet hunter. By staring at over 150 zero stars for nearly a decade, it gave us a treasure map of the galaxy. Before Kepler, we knew of only a handful of exoplanets. After Kepler, we knew of thousands. Kepler's successor, TESS, launched in 2018, continues the mission. Unlike Kepler, which studied a single region of the sky, TESS scans nearly the entire celestial sphere, watching millions of stars for the faint signatures of orbiting planets. These telescopes are our windows into the unknown. But how do they actually find a planet so far away when even our most powerful optics can't see it directly? Imagine watching a moth pass in front of a porch light from miles away. That's what astronomers are doing when they use the transit method. When a planet passes or transits in front of its star, it blocks a tiny fraction of the light. By measuring these dips, astronomers can calculate the planet's size, orbit, and even hints of its atmosphere. This method is incredibly powerful. It revealed planets like Kepler 186 and Kepler 452b, worlds that could, in theory, resemble Earth. But it has limits. Not every planet's orbit lines up just right for us to see a transit. That's where another technique comes in. Stars aren't fixed points, they move, pulled gently by the gravity of orbiting planets. This wobble can be detected through tiny shifts in the star's light, a method known as radial velocity. It was this method that first confirmed planets outside our solar system in the 1990s. And even today, it remains one of the most reliable tools for detecting massive exoplanets, especially hot Jupiters, giant gas worlds orbiting close to their stars. But for smaller Earth-like worlds, we need even more sensitive instruments. Enter the James Webb Space Telescope, JWST, launched in December 2021. With its massive gold-coated mirror and infrared vision, Webb is the most powerful telescope humanity has ever built. For the first time, JWST can study the atmospheres of distant planets. By analyzing the starlight that passes through a planet's atmosphere during a transit, Webb can detect gases like oxygen, methane, and carbon dioxide, the chemical fingerprints of life. Imagine this. One day, Webb or its successors could reveal the presence of living ecosystems on another world, simply from the light of a distant star. That possibility is no longer science fiction, it is science unfolding before our eyes. If you find this as awe-inspiring as we do, don't forget to subscribe to Starsky Science. Each click of that button helps us continue creating deep, fact-based journeys into the cosmos. Thanks to Kepler, TESS, JWST, and ground-based observatories, we now know of over 600 confirmed exoplanets, with thousands more candidates waiting to be verified. Among these, dozens lie in the so-called habitable zone, the region around a star where liquid water could exist. Some of the most promising include Kepler 186f, Earth-sized, within the habitable zone. Kepler 452b, larger than Earth, nicknamed Earth's cousin. Proxima b, orbiting our nearest star, Proxima Centauri. The TRAPPIST-1 system, 7 Earth-sized planets, with at least 3 potentially habitable. But here's the catch. Being in the habitable zone does not guarantee habitability. Venus is in our sun's habitable zone, yet it's a hellscape of crushing pressure and acid rain. Mars, just outside, may once have been covered in rivers and lakes. Habitability is complex, and this leads us to the deeper question. What exactly do scientists look for when they search for a second Earth? Astronomers break it down into key ingredients. Water. Without it, life as we know it cannot exist. Energy, from sunlight, chemical reactions, or geothermal heat. Nutrients, elements like carbon, nitrogen, and phosphorus. Stability, a climate that allows ecosystems to thrive. If a planet has these, it might be habitable. But if it also has detectable biosignatures, like oxygen or methane in its atmosphere, that could be a smoking gun for life. NASA's search is guided by missions like Mars rovers, Curiosity, Perseverance, hunting for signs of ancient life. Europa Clipper, 2020's launch, investigating Jupiter's moon Europa, believed to have a vast subsurface ocean. James Webb Telescope, peering into the atmospheres of exoplanets. Future missions, like LUVOR and HABEX, which could one day take direct images of Earth-like planets. The roadmap is clear. From exploring our solar system to studying distant stars, NASA and international partners are systematically piecing together the puzzle of habitability. Even if we find the perfect candidate, survival is not simple. Take Proxima b. Its star is a red dwarf, prone to solar flares. These flares could strip away the atmosphere and bombard the surface with radiation. To survive, humans might need underground habitats or massive shielding. Or consider Kepler 452b. It's larger than Earth, meaning higher gravity. Walking there might feel like carrying twice your own weight. Could our bodies adapt? Could children born there evolve into something slightly different from Earth humans? These are not just questions of science, they're questions of identity. If we settle another world, do we remain Earthlings? Or do we become something new? But here's something sobering. If habitable planets are common, why haven't we seen signs of advanced civilizations? This is the Fermi paradox, the contradiction between the high probability of life and the silence of the universe. One possible answer is the Great Filter, the idea that somewhere between the origins of life and the rise of spacefaring civilizations, there's a barrier that most species never cross. Could it be that while life may exist everywhere, intelligent civilizations rarely survive long enough to spread? And if that's true, Are we approaching our own great filter? The search for a second Earth isn't just about survival. It's about understanding our place in the cosmos and what it truly means to be human. In the next chapter, we'll journey into the most fascinating candidates, yet ocean worlds, frozen moons, and planets that may hide alien ecosystems beneath their surfaces. Stay with us here on Starsky Science as we continue our search among the stars. And don't forget to subscribe. Our universe is just getting started. In our search for a second Earth, we often imagine a world just like ours: blue skies, green forests, and familiar continents. But what if the most promising candidates for life don't look like Earth at all? What if they are hidden beneath oceans of endless depth, where sunlight never reaches, and alien creatures may already swim? Before we dive into the cosmic oceans, don't forget to subscribe so you never miss our journey into the unknown. On Earth, water means life. From the deepest trenches to the highest mountains, wherever liquid water exists, life finds a way. This simple truth guides astronomers in the search for alien life. But not all ocean worlds are like Earth. Some may have seas that cover the entire surface. Others may hide their oceans beneath thick shells of ice. And some may orbit far from their stars, warmed not by sunlight, but by internal heat. These are the ocean worlds, planets and moons, where vast amounts of water may exist. And in the last 2 decades, they've become some of the most exciting targets in the search for extraterrestrial life. Let's begin with one of the most famous, Europa, a moon of Jupiter. At first glance, Europa looks like a frozen wasteland. Its surface, a cracked sheet of ice, stretching for thousands of kilometers. But beneath that ice lies something extraordinary. A vast global ocean, twice the volume of all Earth's oceans combined. NASA's Galileo spacecraft, in the 1990s, provided strong evidence for this hidden sea. More recently, the Hubble Space Telescope detected plumes of water vapor erupting from Europa's surface, geysers blasting into space, carrying material from the hidden ocean below. This means we might not even need to drill through kilometers of ice to study Europa's water. We could simply fly through these plumes and search for the chemical signatures of life. That's the mission of NASA's Europa Clipper, set to launch in the mid-2020s. It will fly past Europa dozens of times, scanning its surface, its chemistry, and perhaps even sniffing those plumes for traces of biology. Europa isn't alone. Around Saturn orbits a tiny moon, just 500 kilometers wide, named Enceladus. In 2005, NASA's Cassini spacecraft discovered towering geysers erupting from its South Pole jets of water vapor, ice grains, and organic molecules shooting into space. Cassini flew through these plumes and detected complex chemicals: hydrogen, carbon dioxide, methane, the very ingredients that could support microbial life. Imagine, beneath Enceladus's icy crust lies a warm, salty ocean, heated by tidal forces from Saturn's gravity. Hydrothermal vents at the ocean floor may provide energy, just like on Earth, where deep-sea vents support entire ecosystems without sunlight. If life exists anywhere beyond Earth, Enceladus is one of the top contenders. Then there's Titan, Saturn's largest moon. Larger than Mercury, Titan has a thick atmosphere, rich in nitrogen, like Earth's and lakes and rivers. But here's the twist. Titan's lakes are not water, but liquid methane and ethane. On its surface, temperatures plunge to 184 C. Yet, Titan is eerily Earth-like in its geography, with rain, rivers, lakes, and even dunes. Some scientists believe life could exist in Titan's methane seas. Life not based on water, but on entirely different chemistry. Beneath Titan's frozen crust, however, may also lie a hidden water ocean. This makes Titan a double world, with both alien seas of methane and a possible subsurface water ocean. In the 2030s, NASA's Dragonfly mission will send a nuclear-powered drone to fly across Titan's skies, sampling its chemistry, exploring its surface, and searching for clues to life. If this amazes you, you're not alone. The idea that life could be swimming beneath the ice of Europa or drifting in the methane seas of Titan is one of the most exciting possibilities in science. To stay with us on this journey, Remember to subscribe to Starsky Science, your gateway to the universe. Our solar system is full of icy moons hiding oceans. But what about planets orbiting distant stars? Recent discoveries suggest that water worlds may be common across the galaxy. Take GJ 1214b, a super-Earth about 40 light-years away. Observations suggest it could be an ocean planet covered entirely by a thick, steamy atmosphere and a global sea beneath. Another Kepler 22 lies in the habitable zone of its star and may be a super-Earth with a deep ocean. And then there's TOI 1452b, discovered in 2022, which may be covered by an ocean hundreds of kilometers deep, far deeper than anything on Earth. Imagine entire planets where there is no land, no continents, only endless ocean, stretching as far as the eye can see. What kind of life could emerge in such a world? Perhaps intelligent beings that never invented fire or tools, but evolved as massive, intelligent ocean dwellers. The most exciting lesson from Earth is that life can thrive without sunlight. In the crushing darkness of our oceans, at depths where no light penetrates, entire ecosystems flourish around hydrothermal vents, powered not by the sun, but by chemical energy. This means that even in the hidden oceans of Europa, Enceladus, or distant exoplanets, life could emerge in the dark, feeding on heat and chemistry instead of sunlight. If life can adapt here on Earth, why not out there? But what about humans? Could we survive on these ocean planets? The challenges would be immense. On a water world with no land, we would need to build floating cities, like vast ships drifting across endless seas. On icy moons, we might live in domes beneath the ice, tapping into the oceans below for resources. Radiation protection, extreme cold, and lack of breathable atmosphere would all require advanced technology. But the oceans themselves could provide what we need: water, oxygen, hydrogen, fuel. It's not impossible to imagine a future where humanity colonizes these alien oceans, building entire civilizations on worlds that are more water than rock. NASA, ESA, and other space agencies are already designing missions to study these worlds. Europa, Clipper, Dragonfly, and possible future landers for Enceladus are stepping stones. And in the far future, we may send robotic submarines to swim beneath the ice, exploring alien oceans directly. Imagine the first images of alien fish glowing in the dark seas of Europa. Imagine the first human mission to an ocean exoplanet, sailing across alien tides under the light of two suns. As we've seen, the search for a second Earth may lead us not to another planet like our own, but to strange and beautiful ocean worlds, moons and planets where life could already exist, waiting for us to find it. In our next chapter, we'll travel even further, exploring the vast diversity of exoplanets, super-Earths, mini-Neptunes, and strange worlds that challenge everything we thought we knew about the universe. Stay with us here on Starsky Science, and don't forget to subscribe. The search is only just beginning. We've explored icy moons and mysterious ocean worlds, but the galaxy has far stranger planets, giant worlds of fire, frozen super-Earths, and exotic atmospheres that challenge everything we thought we knew about planets. If we are searching for a second Earth, we must understand them all. When we first imagined other planets, we thought they'd be like our solar system: rocky inner worlds, gas giants further out, icy bodies beyond. But exoplanet discoveries have shattered that expectation. We found planets with two suns, planets made of diamond, planets orbiting so close to their stars they glow with heat, and worlds that may rain iron or glass. The truth is, the universe is far more creative than we imagined. Among the most common exoplanets discovered are super-Earths. These are rocky planets larger than Earth, but smaller than Neptune. Some are only slightly bigger than our planet, others up to 10 times its mass. Super-Earths could have stronger gravity, thicker atmospheres, and perhaps vast oceans. Some scientists believe they may be super-habitable, even better suited for life than Earth. Their larger size could give them more stable climates and stronger magnetic fields to shield life from radiation. Exemples include Kepler 62, a super-Earth in the habitable zone, possibly with oceans. TOI 1000, 452b, a likely water world, larger than Earth. Kepler 22b, one of the first super-Earths discovered in a habitable zone. Could humans live on such worlds? Possibly, but higher gravity might make walking feel like carrying a heavy weight at all times. Over generations, humans might even evolve shorter, stronger bodies to survive. Another common type is the mini-Neptune planets, larger than Earth but smaller than Neptune, with thick atmospheres of hydrogen and helium. They may have rocky cores and deep oceans beneath dense skies. These planets may not be habitable for humans, but they expand our understanding of planetary diversity. Some could even transform into rocky planets if their atmospheres are stripped away by their stars. Some of the first exoplanets discovered were hot Jupiter's gas giants orbiting extremely close to their stars. These worlds complete an orbit in just days, their atmospheres scorched by heat. Temperatures can soar above 2.0 C. Winds may blow at thousands of kilometers per hour. On some, molten metals and minerals may condense and rain from the skies. One famous example is HD 189,733b, a planet where scientists believe it literally rains molten glass, driven sideways by supersonic winds. Another, WASP 76b, may have iron vapor in its skies condensing and falling as iron rain. Clearly, these worlds are too hostile for humans, but they remind us the universe is full of extremes. Among the most mind-bending discoveries are planets like 55 Cancri E, a rocky world so hot it may be partly made of diamond. Kepler 70b, a planet that once orbited so close to its star, it may have survived being inside the star's atmosphere. Gliese 581 Ek, once considered a potential Earth-like world, though later studies suggest it may be too hot. Each discovery pushes us to rethink the boundaries of habitability. Not every planet needs to be an exact copy of Earth. Some worlds may host life in ways we can't yet imagine using different chemistries, thriving in extreme environments. But for humans, survival means something narrower. Air we can breathe, water to drink, gravity our bodies can handle, and temperatures we can endure. That's why finding a truly Earth-like exoplanet remains the holy grail. If you're fascinated by the incredible diversity of worlds, don't forget to subscribe. The more we learn, the closer we get to answering the ultimate question. Are we alone in the universe? With telescopes like JWST, astronomers are beginning to detect atmospheres of exoplanets. By analyzing starlight filtered through those skies, we can spot gases like water vapor, carbon dioxide, and methane. These are potential biosignatures, clues that life might exist. Imagine the day we see oxygen in the atmosphere of a distant planet, with hints of water vapor and methane too. That might be the first evidence of alien biology. Already, Webb has studied planets like WASP 39b, detecting carbon dioxide and even signs of clouds. Though WASP 39b is not habitable, the tools used prove we are on the verge of studying Earth-like atmospheres. Let's imagine the possibilities. On a super-Earth, humans might need stronger muscles to move under higher gravity. Cities might be built smaller and denser. Flight might be impossible, but agriculture could thrive under thicker air and more stable climates. On an ocean planet, humanity could build floating megacities, harvesting energy from tides and waves. On a tidally locked planet, one side forever in daylight, the other in darkness, civilization might thrive in the twilight zone, between burning heat and frozen cold. Each type of world presents challenges, but also opportunities. Humanity is nothing if not adaptable. The galaxy is filled with strange and marvelous worlds, super-Earths, mini-Neptunes, hot Jupiters, and exotic planets that defy imagination. Somewhere among them lies the world we dream of, a second Earth, waiting to be found. In our next chapter, we'll explore what it would take for humans not just to visit, but to settle permanently on another planet. Could colonization really be our future? Stay with us as we continue the search for survival beyond Earth. When we think about moving to a new planet, it sounds almost like science fiction. But the truth is, if humanity ever reaches another habitable world, we won't find ready-made cities waiting for us. we'll need to build everything from scratch. And that means reimagining survival in a place where the environment itself may try to kill us. Scientists at NASA, ESA, and other space agencies have been working on ideas for what life on these distant worlds might actually look like. For example, how do you build a home where the atmosphere is too thin to breathe or filled with toxic gases? On Mars, engineers imagine habitats built underground, shielded from deadly radiation. Inflatable domes covered with Martian soil, called regolith, might provide insulation and protection. But what about oxygen? On Earth, we take it for granted. Yet on other worlds, producing breathable air becomes a constant challenge. Experiments are already underway to turn Martian carbon dioxide into oxygen using devices like MOXIE, a small machine tested on the Perseverance rover. Scaling this up could allow settlers to breathe freely. And then there's water. Every single form of life we know depends on it. Transporting water from Earth would be impossible on a large scale. Instead, future explorers must learn to extract it locally from underground ice, frozen crusts, or even by condensing atmospheric vapors. Mars has polar ice caps, and scientists believe beneath its soil lies frozen water waiting to be tapped. But water and air are just the beginning. We also need food. Carrying endless supplies from Earth isn't practical. That's why researchers are experimenting with space farming, growing crops in controlled environments with LED lighting, recycled water, and artificial soils. Imagine greenhouses on Mars, or vertical farms on an exoplanet orbiting a distant star. This brings us to another massive challenge: gravity. On Earth, we live in a constant gravitational pull. Our bodies depend on it, our muscles, bones, and even our blood circulation. But on Mars, gravity is only about 1/3 that of Earth. Long term, this could cause serious health problems. Scientists are exploring artificial gravity solutions, perhaps spinning habitats or specialized exercise routines to help keep human bodies strong. And beyond gravity, there's radiation. Cosmic rays and solar storms pose a deadly risk without Earth's protective magnetic field. Shielding habitats with thick walls, underground bunkers, or even magnetic barriers could help. But these are technologies still in development. Yet perhaps the biggest challenge of all isn't technological, but psychological. Imagine living years away from Earth, under strange skies, in isolation with a small group of people. Mental health becomes as important as physical health. Future colonists will need strong community bonds, structured routines, and perhaps even simulated Earth-like environments to maintain their well-being. Every detail from what we breathe, to what we eat, to how we interact, must be reinvented for life on another planet. It's one of humanity's greatest puzzles. And before we continue, if you're fascinated by these possibilities, don't forget to subscribe to Starsky Science. More discoveries about our universe are waiting for you here. Now, let's move beyond survival. If humans can establish the first homes on another planet, what comes next? Could we truly build civilizations among the stars? If humanity succeeds in surviving on another planet, building shelters, producing oxygen, food, and water, then the next great question arrives. Can we build an actual civilization beyond Earth? Civilization means more than just survival. It means art, culture, technology, families, and generations living not just in spacesuits or sealed domes, but in thriving communities. To reach that stage, we would need to transform a hostile world into something at least partially Earth-like, a process scientists call terraforming. Terraforming has long been a dream of science fiction, but it's also an idea that leading thinkers at NASA, MIT, and ESA consider possible, at least in theory. For Mars, one proposal is to release greenhouse gases into the atmosphere, thickening it over centuries until it warms the planet and allows liquid water to flow. Another idea is to place giant mirrors in orbit, directing sunlight to heat specific regions. While these concepts are far from reality, they show that humanity is already thinking on the scale of planetary engineering. But even before terraforming, civilizations could thrive in massive enclosed cities, giant biospheres built under protective domes or underground caverns. Inside, humans could recreate forests, rivers, even artificial skies. Imagine walking through a park on Mars, Surrounded by green trees and children playing while just beyond the dome lies a lifeless desert of red dust. Yet civilizations are not just physical structures. They are built on human cooperation. How would governments function on another planet? Would Martian colonists remain loyal to Earth nations? Or would they form their own independent societies? History suggests that distance often leads to independence. Just as colonies on Earth eventually sought freedom from their distant rulers, one day Martians or settlers on another exoplanet might declare themselves sovereign. This raises profound questions. What laws would govern space settlements? Who owns another planet? International agreements like the Outer Space Treaty state that no nation can claim ownership of celestial bodies. But as resources become valuable, water, minerals, energy disputes may emerge. Future civilizations in space might write entirely new systems of law, ethics, and governance. Another challenge is economy. Civilizations need trade, exchange, and innovation. On Earth, economies are built on agriculture, industry, and services. On another planet, the economy may begin with survival essentials, farming, construction, and life support. Over time, it could evolve into mining rare minerals, producing new technologies, and even exporting resources back to Earth. Mars, for example, may one day provide rare metals or serve as a base for missions deeper into space. And then there's culture. Wherever humans go, they bring their stories, art, and traditions. Imagine Martian music inspired by the sound of winds across the red dunes. Imagine literature that reflects the struggle of life under a distant sun. Future generations might even see themselves as fundamentally Martian, or members of a new identity, Earthborn versus spaceborn. But civilizations also need energy. On Earth, we rely on fossil fuels, solar power, nuclear energy, and more. On Mars or other worlds, nuclear fusion or advanced solar power may become the backbone of civilization. Scientists already envision orbital solar stations beaming power down to colonies. Without abundant, sustainable energy, a settlement cannot grow into a civilization. Education would also be vital. The first children born on another world would need to learn not just Earth's history, but also how to survive in their unique environment. Imagine schools teaching not only mathematics and science, but also lessons on air recycling, radiation safety, and planetary engineering. These children could grow up seeing Earth as a distant homeland, a blue star in the sky, not their immediate world. As civilizations expand beyond Earth, we may even see new branches of humanity evolve. Different gravity, different atmospheres, different challenges over thousands of years. Could Martians develop physical or cultural differences from Earth humans? Could we one day look at each other as cousins rather than the same species? But civilizations also face risks. History teaches us that great societies can collapse through war, disease, or environmental disaster. On a new world, the risks are even greater. A single failure of life support systems could threaten thousands of lives. That's why cooperation, science, and resilience would be the pillars of survival. Some scientists believe that once we become a multiplanetary species, our chances of survival increase dramatically. Carl Sagan once said, "All civilizations become either spacefaring or extinct. By spreading to other planets, humanity ensures that no single disaster, no asteroid, no war, no environmental collapse can wipe us out entirely." And perhaps, just perhaps, civilizations on other worlds will teach us something profound about ourselves. By building a second Earth, we might finally learn to protect the first one. Before we move forward, a quick reminder: if you're finding this journey into the future of humanity fascinating, make sure you've subscribed to Starsky Science. That way, you won't miss any of our deep explorations into space and beyond. Next, let's take the leap even further. Beyond Mars, beyond our solar system, and out into the galaxy of exoplanets. Could entire new Earths already be waiting for us among the stars? Even if humanity manages to build cities on Mars, terraform planets, and cross the stars, one deep question remains. Should we? Technology might make it possible. Science may tell us how to grow food in alien soil, generate oxygen from thin air, or survive radiation with underground shelters. But philosophy asks us to look deeper to think about what it truly means to leave Earth behind. Earth is more than just a planet. It's our birthplace. Every culture, every language, every story humanity has ever told was born here. When we dream about finding a second Earth, we must ask, are we searching because we want to expand, or because we have failed to protect our first home? Scientists like Carl Sagan warned us decades ago, there is no planet B. While searching for habitable worlds is essential for the survival of our species, it should never become an excuse to neglect Earth. Our oceans, forests, and atmosphere are irreplaceable. Even if we found another Earth-like world tomorrow, it would take centuries to reach it, terraform it, and make it a home. Until then, this blue planet remains our only sanctuary. But let's imagine for a moment that we succeed. Let's say our descendants, hundreds or thousands of years from now, step foot on another Earth. What would that mean for us as a species? Would we carry with us the same mistakes, wars, greed, pollution? Or would we begin again with lessons learned, building societies that value balance, sustainability, and peace? Philosophers suggest that space colonization may not just be about survival, but about transformation. The experience of seeing Earth from afar, a fragile blue dot in the vast blackness, might change humanity forever. Astronauts who've seen this perspective describe it as the overview effect, a sudden realization of how connected and delicate life truly is. Perhaps spreading among the stars could inspire us to finally see beyond divisions of race, nation, or belief, to realize we are all part of the same species, sharing the same cosmic story. Of course, there's also the question of encountering life. What if, one day, we discover another world not only habitable, but inhabited? How would we treat alien civilizations, with curiosity and respect, or with conquest? History on Earth has shown us both paths. Which one we choose among the stars will define the future of humanity. And then there's the ultimate dream, interstellar civilization. Imagine humans living on multiple planets, orbiting multiple stars, connected by vast networks of communication and trade. Some scientists even speculate that one day, humanity could become a Type I or Type II civilization, capable of harnessing the full energy of a planet, or even an entire star. This idea, known as the Kardashev scale, measures how advanced a civilization is by the amount of energy it controls. Right now, humanity isn't even at Type I yet. But every rocket launched, every probe sent, every telescope turned toward the stars brings us a step closer. And maybe, just maybe, finding a second Earth isn't the end goal at all. Perhaps the real journey is learning who we are not just as Earthlings, but as citizens of the cosmos. As we close this chapter, let's remember, searching for another Earth is not just about escape. It's about hope. It's about pushing the boundaries of what we know and daring to imagine a future where humanity thrives among the stars. The next frontier isn't just about space. It's about us. The search for a second Earth has taken us on an extraordinary journey. We began with the origins of life on our planet, explored the harsh landscapes of Mars, the icy moons of Jupiter and Saturn, and the dazzling possibilities of distant exoplanets. Along the way, we imagined the challenges of survival, building habitats, growing food, protecting ourselves from cosmic dangers. We confronted questions of technology, science, and philosophy. But now, as we stand at the edge of this vast cosmic story, the truth is clear. Humanity's survival depends not just on finding a new world, but on how we treat the one we already have. Earth is still the only known home of life. It holds every tree, every ocean, every breath we take. It is, for now, the only sanctuary in the cold vacuum of space. Protecting it is not optional, it is essential. While the dream of colonizing other worlds may come true in centuries to come, the reality is that our future for the next thousands of years is still tied to this fragile blue planet. Yet, this doesn't make our search meaningless. Looking outward forces us to think differently. It shows us how unique our world truly is. Every exoplanet discovered, whether a gas giant, an ocean world, or a rocky Earth-like twin, reminds us of the miracle of life here. The farther we look, the more we understand how rare and precious our home is. And still, the dream continues. Humanity is not meant to stand still. Exploration is written into our DNA. From the first humans who crossed mountains and oceans to the astronauts who set foot on the moon, we have always asked the same question: what lies beyond? Perhaps the discovery of a habitable exoplanet will inspire the greatest journey in human history. Imagine the day when the first starship leaves the solar system, carrying generations of humans toward a distant sun. Imagine the first child born under alien skies, the first civilization built beyond Earth, the first poem written on another world. These are not fantasies, they are the logical next steps of a species that refuses to stop dreaming. But the greatest lesson of our search for a second Earth may not be about the stars at all. It may be about perspective, about realizing that in the vast universe, we are small but not insignificant. We are the storytellers, the explorers, the builders. We are the ones who look up at the night sky and see not emptiness, but possibility. The choice before us is simple. We can destroy ourselves with war, greed, and carelessness. Or we can unite, innovate, and reach for the stars. The story of humanity is not finished. The next chapters are being written right now in the laboratories of scientists, the classrooms of children, and the dreams of people like you. So when you look up tonight, remember, every star you see is a sun, and around those suns may be planets waiting for us, waiting for the day when humanity takes its next leap into the unknown. We may never find another Earth, but the search itself reminds us of who we are, explorers of the infinite. And as we continue this journey, one message must echo across the centuries: protect Earth, dream of the stars, and never stop searching. Thank you for watching this journey with us. If you want to keep exploring the mysteries of the universe, don't forget to subscribe. More stories of space, time, and discovery are waiting right here on Starsky Science. The universe is calling. Will we answer?